So hello everyone, welcome back, and here is the final day where we are going to discuss all those questions which were asked previously, and also it will include the test in which most expected questions are there. And do not worry, as per promise, in the ending of the session I'll give you the free MCQ PDF which will be available on the application part, where under YouTube section you can just download the whole PDF, that is your ebook is ready, and this will be continued now every week. So this time we are discussing the three topics which we have discussed on Tuesday, Wednesday, Thursday. What is it? Scalar vector quantities, point number 1. Then we discussed about electricity, second, and then we discussed about magnetism. So what kind of questions are framed, how we can attempt them? Let's have a look at those questions. So what is the first question? The first question is present here. What is it? Magnetic permeability of which substance is maximum? So is it diamagnetic, paramagnetic, ferromagnetic, or all of the above? So for attending this question, we must understand first, guys, what is diamagnetic, what is paramagnetic, and what is ferromagnetic. So guys, it's basically the property of the substances. So let's say if I'll ask you about the plastic. So if I'll place the plastic in the magnetic field, will it generate magnetism? Obviously not. But yes, if I'll place copper, if I'll place silver, or if I'll place iron, they will develop magnetism. But what level of magnetism is developed? That's a different point. So yes, if I talk about the diamagnetic or paramagnetic substances, they develop the feeble magnetization. But if I talk about the strongest magnetization, that too in the direction of the magnetizing field, that's ferromagnetic substances. And here, iron or alnico, they all are included. So according to this question, what do you think? What is the correct answer? So here, magnetic permeability of which substance is maximum? So obviously that will be ferromagnetic. That is option number C is going to be the correct answer. And do not worry, as promised, I'll give you the explanation also, and the candidates who are from Hindi medium background also you can revise it. I mean the candidates who are from the belt on which can understand Hindi, they can also revise it from here. But obviously since this channel is in English medium, so I have prepared whole content in English also. So this will be there in each and every question. So first of all, ferromagnetic substance as discussed, it's very strongly attracted by the magnet, and the importance of iron as a magnetic substance has led to the name of these as the ferromagnetic substances. Above the Curie temperature, this line is very important. Above the Curie temperature, they have the same behavior as that of paramagnetic materials. Okay, so here the correct answer was ferromagnetic, that is option number C. What's the next question? The next question is in front of you, and the question is the unit of magnetic flux is dash. So tell me. So amount of lines that are passing through a particular area. What do you think? So Pawan is asking, sir, is it a new series? Yes, Pawan, it's a new series, and in this new series, we'll be discussing the theory in the starting of the week, and on every Friday, we'll have discussion on those topics, which is going to give you the clarity about the previous year paper and also the type of questions which are asked in the examination. Okay, so what about this question? What is the unit of magnetic flux? So that's the easy question, and we are aware of. If I talk about it, so guys, what is the answer? Should it be Weber? Obviously yes. So guys, yes, the answer will be Weber. But how do you calculate this magnetic flux? So for calculating this, we have a formula that is B into A. So let's have a discussion in the detail now. So for this question number 2, we have explanation here. What is magnetic flux? The number of magnetic field lines passing a surface area normally is called magnetic flux, which is noted by phi, right? And here, that's the formula which we already discussed. So here, what is the unit? So that is your Weber, right? So the SI unit of magnetic flux is equal to the SI unit of magnetic field into the SI unit of area, that is Tesla meter square, or we can link it with Weber. Please remember this because many of the students have confusion. So why you are writing Weber? It's Tesla meter square. So they all have the same relation. This relation is important to understand. Fine. So yes, I have specially mentioned here, Tesla meter square is always equal to Weber. Done. Next, what is the next question? The next question is in front of you. Let's see what is that. Magnetic field lines produced by a current carrying conductor are dash. So this we have discussed yesterday. What should be the correct answer? So what do you think? Is it parallel to each other, semicircular in shape, concentric circles, or intersecting lines? So the direction of the magnetic field is always perpendicular to the direction of current flow, right? So here they are asking magnetic field lines produced by the current carrying conductor are dash, parallel to each other, semicircular in shape, concentric circles, or intersecting lines. So for this question, let us see who is giving the answer. Okay, so there's a confusion, right? But do not worry guys. So it is what? The magnetic field lines around a straight current carrying conductor are concentric circles. And yes, Pawan, you are absolutely correct. It will be concentric circles. That is option number C is going to be the correct answer. Perfect. So let's have a discussion again here. So as discussed, direction of the magnetic field is perpendicular to the direction of the current flow. But yes, the magnetic field lines around a straight current carrying conductor are concentric circles that are centered on the conductor. Okay, so yes, I am going to share this PDF with you so that you can easily revise, and also you will be prepared for examination. What's the next question? The next question is, okay, so yes, this is the diagram by which you can actually relate it. So here, these are the magnetic field lines and it is showing that it is anti-clockwise. So that's the current upwards. So guys, if you remember, we were discussing about this rule, right? So this thumb was denoting the this current, and this fingers, they were denoting the magnetic field lines, and this can be linked with the screw rule as well. So you can use any of the concept, but you will get the same answer. Next, what is the next question? The next question is, an electromagnet is dash. This was discussed in the yesterday's class itself. So magnets are of two different types, right? So if I talk about this electromagnet, what is it? So here we have that solenoid like structure. We have solenoid. What is it? That is the copper coilings are there, in which soft iron core is used. Yes, this is the important one. So what do we use there? We use soft iron core. This was the question from the previous year paper. So here, what is electromagnet? So guys, if I talk about a magnet, so magnet is divided into two different parts. One will be the temporary one and another one is the permanent one. So permanent magnets are the ones which continue to have the magnetic property till a longer period of time. For example, horseshoe magnet or the bar magnet. What about electromagnet? So electromagnets are temporary in nature. The reason is it only shows the magnetism till the time the power supply is given. Once the power supply is off, magnetic property is gone. So yes, here electromagnet is actually the example of a temporary magnet, and hence we will say that option number A is the correct answer. We have already understood this. So guys, I have brought the image also for better explanation. So see, a current carrying conductor produces the magnetic field around us. That's right. The magnetic force depends upon the magnitude of the current and the distance of the conductor, and this property of the current is used to make an electromagnet. So here, electromagnet is a temporary magnet. Why? Because it should ideally have the property to behave as a magnet when the current passes through it and loses the magnetization as soon as the current is stopped. Structure, I'll just show you. This is the structure. So guys, here's a battery that is connected here, and yes, because of the potential difference, as we know, current always flows from higher potential to the lower potential. That can be understood here. So that's the structure that is showing the solenoid part. So there's an electromagnet, and it's a temporary magnet because it will lose its magnetic property once the current supply is turned off. Okay, next, what is the next question? The next is, the purpose of an amplifier is dash. Let's go towards the electricity part now. So what should be the answer? Pawan is saying something. Yeah, that's the right hand rule, right? So what is the main purpose of an amplifier? To increase voltage, current or power of an input signal, to attenuate the signal fed to its input, to introduce distortion in the signal fed to it, or B and C both will be the correct answer. What do you think? What should be the correct answer? So to increase the voltage, right? To increase the current. So that's also mentioned here. And then both voltage and current should be the answer. So here guys, what should be the answer? In this case, I can just see that for both voltage and current, it's mentioned here. So what we can say, that we'll go with option number A only. So the purpose of amplifier is to increase the voltage or current or the power of the input signal. So what is the correct answer? A, right? Next, what is the next question? The next question is this. At the time of short circuit, the current in an electric circuit is dash. What do you think? It becomes 0, it remains same, it increases sharply, or it decreases sharply. So guys, if someone asks you about the short circuit, what is it? What do you think by it? What do you mean by short circuit? So guys, here the current actually increases rapidly. It increases exponentially, rather I can say. So it becomes 0. No, that's wrong. So it remains same. No, it increases sharply. And yes, we'll go with option number C here. So here, the flow of current takes place through a very low resistance. So since there is very low resistance, current supply will be more. So yep, here the correct answer is going to be option number C. So short circuiting means the increment in the current. So in this case, current does not face any restriction because resistance is low. So obviously current will move with a faster pace, right? So as a result, current flow increases abruptly, and hence we can say current in the circuit is increasing sharply. So during this time, current has very large magnitude. It occurs when the neutral and the live wires come into the contact. Okay. So guys, in order to prevent from the short circuiting, do we have any device? Yeah, we have certain devices, and out of them, fuse which were used earlier, but as of now, MCBs would be the perfect examples of fuse which used to have a wire. And what were the properties? So for the fuse, you must remember this fuse used to have the wire which had low melting point. Why low? Because if heat is generated, obviously heat will be generated, and that's according to what law? That's according to the Joule's law of heating effect. What is the formula? So the formula is H is equal to I square RT, where heat is generated when current starts to flow through it. And what's the relation? This is relation. This is according to Joule's law. That's it. Okay. So what is the full form of MCB? That is miniature circuit breakers. That's all. Proceeding forward to the next question. Okay. So here's the magnet. The region surrounding a magnet in which its influence can be felt is called its dash. Is it magnetic induction? Is it magnetic screen? Is it magnetic field? Or is it magnetic flux? What should be the correct answer, guys? What do you think? So Pawan, do you have any answer? Yeah, that's correct. So Pawan is saying it will be magnetic field. And what about other candidates? So guys, here, since we are talking about a magnet, now there are invisible lines which we cannot see. They are magnetic field lines. So how we can judge? Okay, so there's a magnetic field line. Is there any concept behind it? Yeah. So guys, see, these are imaginary lines, but we can actually plot it by using the iron fillings, and also we can find the direction by using that magnetic compass. So these are magnetic field lines, and magnetic field lines, magnetic field. So yes, option number C is going to be the correct answer. So let's go into detail now. Magnetic field and magnetic lines of force. It is the space around a magnetic pole or magnet or current carrying wire within which its magnetic effect can be experienced, and that's defined as the magnetic field. So guys, yes, one more thing. Just have a look over here. So in this image, I'm going to explain you three things which are very important to understand. First of all, this is a bar magnet that is present in front of you. Here, you can just see that there are two poles. So we know magnets always exist in the dipoles, right? So since they exist in the dipoles, this is the north pole, this is the south pole. So from where to where these magnetic lines of force reach? So outside the magnet, it moves from north towards the south. Mark my words, where? From north towards the south, but within the magnet, it will be from south to the north, right? So these are few things that we must remember because it is asked in the examination. Now, another point, sir, magnetic field lines always forms a closed loop, but they never intersect each other. Again, yes, they will form the closed loop, but they will never intersect each other. So these are the questions which might be asked in your examination statement wise. That's also clear. Next, what is the next question? Next we have, which of the following forces is not an electromagnetic in nature? Is it force of friction, tension, electric force, or weight of the body? What should be the correct answer, guys? What do you think is the correct answer? So electromagnetic force is a type of physical interaction that occurs between the electrically charged particles. It acts between charged particles and a combination of all electric and magnetic forces. So it can be repulsive or also attractive. So you have four options. Tell me. Force of friction, tension, electrical force in the spring, or the weight of the body. What do you think? So here, the weight of the body is not electromagnetic, because if I talk about it, so weight of the body is the gravitational force acting on it, right? So this force depends upon the acceleration of the gravity. So here Pawan want to say something. Pawan is saying, sir, outside it, it's north to south and inside south to north. Yeah. So, Asha, you want some trick for the same? Okay, I'll just give you the trick. 1 second. So here, the question was which is not. So that's actually the weight. So option number D will be the correct answer. So Pawan, you wanted the trick, right? So I'll move back again. Now guys, one of the candidate has a doubt. So is there any trick to remember that outside the magnet it will be from north to south? So is there any trick for the same? Okay, so guys, outside the magnet it is what? North to south, right? So here, do you know this term sin? So why are using this term sin? You can easily link it, right? Or you can link with the one second. So you can link it with sin. That will be the best part. So guys, in this sin, it will be easy. So inside the magnet, it is going to be south to the north, right? And yes, here just sin trick will work and the opposite concept can be linked here. So you can create your own tricks. Actually, it is an English medium channel, so I could have given the Hindi medium tricks also. But you can link it with these short terms. You can create your own mnemonics for the same. Okay, so sin would be the best example. So for the trick, you can just remember sin. So normally it moves from north to south, but it's a sin that if I'll check within the magnet, just opposite concept is happening. And what is it? That the lines are moving from south to the north direction. That's it. Okay, so proceeding further, so that's done. When a number of resistance are connected in dash, their combined resistance is less than the smallest individual resistance. So horizontal, box, series or parallel. So guys, since we are talking about circuits here, so it doesn't make any sense to go with horizontal or box. As we are aware of, we are talking about a circuit in series. Now guys, this is the best part. Let's say it is of 5 ohm and it is of 6 ohm, right? So guys, if I want to know the equivalent resistance between points A and B, how you will calculate? So since when current will pass here, current has no other path. Since current doesn't have any other path, so current will be same everywhere. So sir, this means it is a series circuit where current is same. That's the point number 1, which is very important to understand. But the potential difference is going to be different. Potential difference will be different or voltage will be different. So now in the series circuit, if I want to calculate the resistance, that can be easily calculated by this particular formula because only 2 are there. So it will be 5 plus 6 and it is going to give you 11 answer. So what was the question? The number of resistance connected in dash, their combined resistance is less than the smallest individual resistance. So the overall is 11 and smallest is 5. So is this concept working with the series? No sir, that concept cannot work with the series. What about parallel? If these connections would have been in parallel, if they would have been in parallel, we would have used the formula 1 by r is equal to 1 by 5 plus 1 by 6 and it would have given me LCM as 30. So 5 6 are 30 and 6 5 are 30. So it would have been 11 by 30, right? So if I talk about the overall resistance, so it would have been 30 by 11. That means 2 point something. So 2 point something. That resistance is smaller than the smallest value if it would have been in parallel, and that's why parallel is the answer. So no need to go with the rectification part. It's as simple as that. If your basics are clear, everything is clear, right? So we have few comments. Let me check. Pawan want to say something? So yeah, that's correct. Absolutely fine. So yes, we have discussed this and addition this series. That's the formula. And for the parallel part, this is the formula. One more thing, in the series, current is same, but in the parallel, current is different, and that's asked in the examination again and again. So in the parallel, current is different. Okay. So again, guys, I'll repeat the same statement. That on the every Friday we'll be discussing the questions which are related with the previous year paper and the most expected ones that we are discussing right now. And after the class, you'll get these free e-PDF that our team is creating. I'm just suggesting them what to create. So you will be getting that free PDF on every Friday. And this session will be useful if you will watch the theory classes first. So theory classes will be on Tuesday 5 p.m., then Wednesday 5 p.m. and then Thursday 5 p.m. And by combining those 3 lectures, you'll get the session which will be like this on every Friday. So yes, on Monday we'll have the mock test at 5 p.m. and Tuesday, Wednesday, Thursday the theory classes, and on Friday this mixed question along with the free PDF. So yes, do subscribe our channel and do not miss these classes. Okay, next. So the next question is, if the current is doubled and the potential difference is reduced to half, then what is going to happen? Resistance will become 1/4, resistance will be doubled, resistance will be halved, or resistance will become 4 times. What do you think? What is the correct answer here? And guys, it's as simple as that, because if you are able to link it with the Ohm's law, you will get your answer easily. What is it? So according to the Ohm's law, if other conditions are kept constant, voltage is directly proportional to the current, right? Now, if I want to remove this proportionality sign, what I can do? I can use a constant here, and that constant is R. So I'll get a formula that is V is equal to IR, right? Now tell me one thing. If the current is doubled and the potential difference is reduced to half, so what will be the change in the resistance? So resistance is equal to R will be equal to V upon I, and the new R will be equal to current is doubled, so that is 2I, and potential difference is reduced to half, and potential difference is reduced to half, that is again 2. So it will be 1/4 V upon I, right? So 1/4 V upon I have my answer. So resistance has become 1/4. So 1/4, and that's your answer, right? So is it okay, guys? No, Pawan, that's wrong. That's wrong, mere bhai. Here that would not be the concept. I'll do one thing. I'll take a blank page in order to make you understand this. So I guess everything is clear till here. V equals to IR. This concept was clear. So I'm taking an extra page. I'll just use the board. That's my favorite teaching background. And here I'll write it for you. Guys, the formula that was V upon I, right? And the new resistance was this. It was V upon 2, right? And here the current was doubled. So here into 1 upon 2I. It will be like this only, na? So it will be, guys, 1/4 V upon I. So V upon I is here. So what's that? It's 1/4. That's the equation number 1. So R new will be equal to 1/4R. That's the point. So understood. So do not give the wrong answer. That would be wrong. Yeah, now you are correct. So yes, this concept is also clear. Proceeding further. Okay. Next. So the next question is, so we have linked with this part. Okay. Tunnel diode is an PN diode with dash. So this was the question from the RRB. So it was asked in the railways. Same question was asked in ALP part as well. So what do you think? Tunnel diode is a PN diode with dash. Very high doping in P region, very high doping in N region, very high doping in both P and N regions, low doping in both P and N regions. What do you think? What should be the correct answer? So tunnel diode is a highly doped semiconductor diode. So the P type and the N type semiconductor is heavily doped in a tunnel diode due to the great number of impurities. So heavy dope results in the narrow depletion region. So guys, just try to link it. What is it? Very high doping in both P and N regions, and that's why the correct answer is C. That's great, guys. Perfect. Next. So C is the correct answer. Heat is measured by dash. So how will you measure heat? So it's the question from the devices and their uses, or instruments and their uses. I'll just take this side here. So guys, there's a thermometer, calorimeter, pyrometer, thermocouple, and that's an important question. Why is it important? I'll just explain you. But as of now, I got this answer from everyone, and most of the candidates give the wrong answer here. So it's a humble request, try to answer this. Thermometer, I knew it might create confusion, guys. Thermometer is not the answer. So yes, that's why these sessions are important. Guys, what happens? As soon as we see thermometer, we try to link it with the heat. But that's not heat, guys. Thermometer is used to measure the temperature. Thermometer is used to measure the temperature. That's not for the heat. and most of the candidates, it's not wrong with you, Pawan, it's actually wrong with everyone. So back to school tales. Here the answer is going to be a calorimeter. The perfect answer will be calorimeter, and there's a way to remember this. So what is the unit of heat? Tell me. So you are calculating that values in joules, right? So what is that unit? So that unit is joule, or we can link it with the calorie. So the meter, that is device that is measuring the calories, that is heat. So for the heat, we'll go with the calorimeter, guys, right? So that's the priority that can be given. So for measuring the higher temperature, we can go with the pyrometer. Pyrometers are used when you are measuring the temperature using radiations. So the perfect answer is going to be your thermometer, calorimeter. That is option number B. Okay, so calorimeter is used to measure the enthalpy, the heat energy of a reaction. Thermometer was a device for measuring the temperature. 1 second, because Pawan, you have given this answer. That's for measuring the temperature. Pyrometer is used to measure the very high temperature. So pyrometer is used for measuring the high temperatures. And thermocouple, that's again thermocouple. From therm term, you can link it with this part. So it's used for measuring the temperature, that consists of the pair of wires of different metals or semiconductors that are joined at both the ends. So who was giving that answer? So back to school. I guess this part is clear. Yeah, that's the point. So that's great. So yeah, back to school and Pawan. Now you will never be wrong here. I am damn sure. Great. Next. So at what temperature can a water exist in both the liquid and solid states? So guys, what will be the perfect answer for the same? What do you think? And I have an experiment here to explain, but first of all, you will answer, then I'll explain it. Okay, so by the time you're explaining, I'll just make an ice cube for you people. So yeah, please comment. By the time, let me make an ice cube for you people. Okay. Okay. So guys, this is an ice cube, and let's take a feel that you have just taken the ice cube out from your freezer, right? And you have kept that ice cube on your palm. Now, forget what's written on the board. Tell me one thing. If that ice cube is kept on the palm, at this time, the ice has how many states? I mean, the H2O has how many states? That's the simplest question I can ask. So guys, please remember, when your ice cube will be kept on the palm, within 2 or 3 minutes, your ice will start to melt. And since ice has started to melt, that means obviously it was in solid state, but it will also be present in the liquid state, right? So at the same temperature, solid state is also there, liquid state is also there. So obviously the temperature will be same, and that will be 0 degrees centigrade. That's done according to the question. But now I have another question, because there's a point that is known as triple point, and I'll explain that. So by the time, let me check with the comments. So Pawan, acha, okay, sure, Pawan, okay, fine. So if you will have doubt, you can just ask me in the comment section. Now guys, the point is, if that ice cube is kept on the hand, and if we see it clearly, at the same time you will find vapors as well. So at the same temperature, the ice cube is going to have 3 different states. It will have the vapor state, liquid state, and the solid state. And since it has 3 states, that's known as the triple point of water. What is it? That's known as triple point of water. And if I talk about this triple point of the water, so guys, here, this ice cube, this liquid part, and the vapor, so all these 3 states are present at 0.01 degree centigrade, and this is known as triple point. Understood? So what is known as triple point? Because here water is present in 3 different states, and that's the point. Okay, so here the answer was B. We have understood this. Next, water in an electrical kettle becomes hot by dash. So water in an electric kettle becomes hot by dash: conduction, convection, radiation, or motion of its molecules. What do you think? So guys, if I talk about the transfer of heat, so heat gets transferred in 3 different ways. One is conduction, in which molecules just vibrate, they don't change their positions. Convection, where the particles actually change their positions. And then radiation, which doesn't require any medium, like the energy which comes from the sun towards the earth, right? So here, among us these options, convection would be perfect answer because convection takes place in the fluids. That is, it can be the gas also, it can be the liquid as well, right? Okay, so that's done. Now guys, since these topics are from heat part, I'll just ignore it. I'll obviously share these questions, but let's proceed towards this electromagnet part again. Which of the following is the most suitable for the core of an electromagnet? And that's the question from your previous part. So we have discussed this when I was discussing the electromagnet. So you have the option, tell me. Is it air? Is it soft iron? Is it steel? Or is it none of the above? So for making the core of an electromagnet, what can be used? And see, the core is used in the solenoid for the production of the strongest magnetism. And here, what do you think should be the correct answer? So here, back to school, you were correct. So here the answer will be what? Soft iron. Absolutely correct. That's great. Back to the school. Acha, can you please tell me what's your name so that I can take your name? So yep, here the correct answer is going to be your soft iron. That is option number B. So soft iron is selected for making the core of an electromagnet. Next, which of the following is found in the sun as a nuclear fuel? Is it helium, carbon, oxygen, or hydrogen? So here's in the sun, what should be the answer? So at the sun, some nuclear fusion takes place. What is that? Nuclear fusion takes place. What is fusion? The smaller nucleus combines together to form a larger nucleus. So which of the following is found in the sun as a nuclear fuel? That's hydrogen, and this is the only reason because of which we are able to survive, right? So we plants, we all are able to survive because of this hydrogen only. Next we have, on increasing the temperature of a semiconductor, its resistivity dash. So what happens on increasing the temperature? So resistivity of the semiconductor is actually inversely proportional to the temperature due to their negative temperature coefficient. So now, since I've explained this, I guess you can directly give the answer as well. So what should be the correct answer? So here, acha, okay Charan, fine. So Charan, as discussed, that resistivity of the semiconductor is inversely proportional to the temperature due to negative temperature coefficient. So obviously, here we are increasing the temperature, so it will decrease, and that is option number B is going to be the correct answer, right Charan? Next we have, okay, so we have completed electricity, magnetism, and some part of heat also. So now it's the time to understand the scalar and vector quantities, which we discussed on Tuesday. So Tuesday's lecture was on scalar and vector quantities. Let's check we are aware of all those things or not. So first of all, let me give you short revision. See, scalar quantities were the ones that had only magnitude only. But vector quantities were the ones which had both magnitude and direction. So this is the basic part. But one more thing is to be added here. And what is it? For the vector quantity, it must follow vector law. What is it? Guys, it must follow vector law. We are talking about vector here, right? And if I talk about the scalar quantities, sir, if it is not following a vector law, even though it has magnitude and direction, but it doesn't follow any vector law, at that time, the quantity will be considered as scalar. Okay, let's see what kind of questions are framed here. First of all, which of the following quantities is a vector quantity? So your four options, tell me, what do you think, which of the following is a vector quantity here? Work, time, weight, or electric potential? Answer please. Which of the following is a vector quantity? Acha guys, one more thing. If I talk about force, what is the unit of force? That is Newton. And according to the Newton's second law, there's a formula that is derived, that is F is equal to m into A, right? Force is a vector quantity because it has magnitude and also it includes direction. For example, this is the water bottle that I'm having right now. And if I give 5 Newton's force over here, I'm just pushing it with the 5 Newton's force. It is moving on the left hand side. If I give 5 Newton force from here, it will move in the right hand side. What if I give 5 Newton force on both the ends? So guys, this bottle is intact at its position. Bottle is not moving. The reason is So the net force is 0, right? So here we are using the direction. Like when we are talking about this 5 Newton force, it will be written as 5 I cap. When I'll discuss about this 5 Newton force, guys, it will be written as 5 of minus I cap. And when you will try to add it up, 5 I cap plus 5 of minus I cap, so its total value will be 5 I cap minus 5 I cap, that is 0. So the net force is 0. This is what algebraic sum is, right? So here it is following the algebraic sum. It has both magnitude and the direction. So force is a vector quantity, and just like force, you must remember force and weight, they both are vector, and that's why weight is the answer. Asha, one more thing. Charan and all the other candidates who are present in the class, I'll ask one basic question, and you might be wrong here, but please try to answer. Guys, what is the unit of weight? What is the SI unit of weight? Please answer. I won't give any options here, but I won't answer here. Very basic question, right? But it creates confusion. That's the question from the examination, and most of the students have given wrong answer here. So it's a humble request, please answer. What is the SI unit of weight, guys? Now, are you going to say that kilogram? If yes, I'm sorry to say, but the answer is wrong. Why? Because kilogram is actually the unit of mass. It's not a weight. What is the unit? So the unit of the weight is Newton. What is that, guys? The SI unit of weight is Newton, which is noted by capital N. So please remember this. It's a very important part. So that's why we can say, see, the formula for the force is M into A. Similarly, the formula for the weight is M into G, where G is acceleration due to gravity. Understood? See. So this is the reason why these questions are important. Next, which of the following is a vector quantity? Again, the same question. Which of the following is a vector quantity? Electric current, electric flux, electric field, or none of the above? So guys, now in this case, here you might be thinking, sir, electric current will be the vector quantity, right? But current is not a vector quantity, although current has magnitude, although current also has direction, but guys, that's not a vector quantity. Why? Because I've already explained this in the very starting. It doesn't follow the vector sum, guys. It follows algebraic sum. So if you are actually in the doubt, I have already taken this session, so that's present on your channel. I'll just show you where. So on our channel, you'll just go to the YouTube part. Let me show you. So I'll just create the playlist. So guys, on our channel here in the live section, it was discussed on Tuesday. So I'll just click here. And in all the classes, I'll show the animations. Next week, we'll discuss the bio part. In that also we'll discuss. So here, let me go with that part. So scalar and vector quantities, see here. In the scalar vector quantities, I've taken the whole session with this animation only. And here, let it play. So this is where we discussed about the scalar and vector quantities that's mentioned here. Okay. So for the current part, since I explained here, I'll just show it to you. Here there was an animation via which I was explaining you how this things are considered to be the scalar or vector. So what happens in the case of current, when current is actually flowing, so obviously it has a direction and it has magnitude as well. But just like force, if 10 ampere of current is coming from here, 10 ampere current is coming from here. So at that particular point where they are meeting, at that time it is going to have 20 amperes of the current. It will not be 10 I cap minus 10 I cap and it would be 0. No. Here it would be the normal mathematical sum. Okay, so you can just watch this lecture. I have already told you where it is present. So you can go in the live section and you can check it. So I'm coming back to my point. Okay, so current is actually the scalar quantity because of this algebraic sum. So that cannot be the answer. So here the electric field will be the answer. So electric field is actually a vector quantity which has both magnitude and direction, right? Why not A? I've explained the reason. Next, So here the C was the correct answer. Which of the following is not a vector quantity? Guys, what should be the answer? The question is which is not a vector quantity? Displacement, temperature, drag or force. So as we know, so force is a vector quantity, right? So displacement is a vector quantity and again drag, but not temperature. So since it is asking which is not a vector quantity, so the answer will be temperature here. And what is the SI unit of temperature? Is it degree centigrade? No. Is it degree Fahrenheit? No. Is it Rankine? Again no. Is it Reamer? Again no. What is that? So the SI unit of temperature is Kelvin. And what is the device that we are using it? So the device for measuring it is thermometer, right? Okay, then this is also done. Which among the following is a scalar quantity? Tell me. So speed, displacement, velocity or acceleration. So obviously all these three are vector quantities. Speed will be your scalar quantity. So what is the answer? A, that is speed is the correct answer. I've already explained everything about it, so no need to go with the explanation here. Physical quantities which have only magnitude and no direction are scalar quantities. So scalar quantities can be specified by a single number along with the proper unit. So mass, speed, volume, density, time, temperature, electric current, they all are the examples of scalar quantities. Right. Next, what is the next question? Next we have, before moving forward, so as all the things which are important, I have taken much time here to create these slides. I'll just upload it just after finishing the session. Do not miss these slides because the number of questions which we are discussing now, if you will go with these particular explanations, the number of questions which we are discussing, you can just multiply it by 5 or 6. These many questions can be linked from here. So yes, please go with the explanations because many things which are important, it's mentioned here. Okay, next. Which of the following is true about mass and weight? One of the most important question from your previous year part. Mass is a vector quantity whereas weight is a scalar quantity. That is the statement number 1. Second is both mass and weight are vector quantities. Third one is both mass and weight are scalar quantities. The final one is mass is a scalar quantity and weight is a vector quantity. So guys, weight and force was one and the same thing if you remember, right? So let us see what will be the answer. So here D, you are going with D? Fine. So Charan is going with D guys, and here he is absolutely correct because mass is scalar where the unit for the mass was kilogram and the weight was a vector quantity where it was linked with the force and here the unit is Newton. Absolutely correct. So D is the correct answer. Next. Which among the following can become negative? Which of the following can be negative? Tell me guys. Speed, mass, velocity or distance? Can speed be negative? No, so that's a scalar quantity, right? Can mass be negative? No, mass cannot be negative. What is mass? The amount of matter contained in a body. That's what mass is. Distance, that's a scalar quantity. It's not displacement, it's distance. So yes, velocity can be negative. So that is option number C will be the correct answer. Next. Which of the following is a vector quantity? Magnetization, relative magnetic permeability, magnetic flux or magnetic susceptibility? What do you think? So magnetization of what? Which of the following is a vector quantity? So see, the direction of the magnetization indicates the alignment of magnetic moments within the material, right? So here we can easily link with option number A because it is representing the magnetic moment per unit volume of a material. Here the best option is option number A. No need to move forward. So I'll go with option number A and that's correct. Next. Which of the following is not a vector quantity? Again guys, which is not a vector quantity, that means in short needs to know about the scalar quantity. Simple. So guys, is it weight? No. So is it nuclear spin? Tell me fast. So again sir, no. Is it momentum? No sir. That's the product of mass and velocity. Is it potential energy? Right. M into G into H. So energy is the quantity that only has magnitude. Energy, for this energy doesn't require any direction, right? So it is a scalar quantity and not a vector quantity. So I'll go with this potential energy. That concept is also clear. Acceleration is dash quantity. Acceleration, that's a vector quantity. So no need to discuss here. That's in vector quantities guys. Next. This is also done. Which one of the following is a physical quantity? So guys, if I talk about this physical quantity, so physical quantity is the one which can be measured and can be easily defined, right? So yes, it can be easily defined, so we can use it for the measurement. So is it Kelvin, gram, meter, or length? So you have four options. So physical quantity is a property of the material which can be expressed in number by measurement. So Kelvin, gram, meter, or length. Physical quantity. So physical quantity can be expressed by numeric value and a unit. So here, tell me if I talk about the 4 meters, then so it can be length also, right? It can be mass as well. It can be temperature as well. So these are the physical quantities. These are physical quantities, and you can link it with the fundamental quantities as well, because it does not derive from any other quantity. Now this question might look typical, but it's not. So Kelvin is not a physical quantity, that's a unit. Gram is not a physical unit, physical quantity, that's a unit. Meter is not a physical quantity, it's again a unit, but length is a physical quantity. So yes, here length, that is option number D, was the correct answer. And let me check, what is the answer? That's great, Charan, absolutely correct. D will be the perfect answer. That's right. So what is the reason behind it? We have understood that also. Which of the following physical quantity is dimensionless? Which doesn't have any dimension? What should be the answer? So guys, what is dimension? How do you calculate dimension? So for calculating the dimension, guys, you must remember m is written when we calculate when the unit is of mass is given. For L is for the length and T is basically for the time. So let's say I'm talking about speed. The unit is meter per second. Meter is the unit of length, right? So that's L. Second is for time. So it will be L by T. So we can write M0 L T minus 1. So that's the dimension of the speed. But if there is no such unit, whereas there would be no such dimension as well, right? So angle is the ratio of the length of the arc of the radius. So if both the things have the same unit, so obviously it will not give any dimension. It will be unitless, right? If it is going to give you one value. So angle, strain, specific gravity, all of the above will be the correct answer. They all are dimensionless. Understood? So if you want that in detail, don't worry, I mentioned that also. See, an angle is the ratio of the length of the arc to the radius. So here also length, here also length. That will cancel out each other. So guys, that's done. Strain, that is the ratio of the change in the length to the original length. Again, length upon length, that is meter upon meter. Again cancelled. Specific gravity, the ratio of the density of a substance to the density of the given reference material. So density upon density, again sir, unitless. So unitless, it means dimensionless. Simple. So that's the point. So that's why all were the correct answer. Next is, consider the following physical quantities: distance or displacement, work power, force, momentum. Okay, so these are 3 points. Which among the above pairs is, which one is a scalar quantity and the other one is vector, but both are measured with the same unit measurement? Okay, so guys, it's saying that which of the following is, one is the vector quantity, one is the scalar quantity, and it's actually measured with the same unit. So what do you think? So here guys, if I talk about distance and displacement, so distance is it also has unit meter, that also has unit meter, or we can link it with the kilometer as well, right? Both have same units. And so this is the distance is actually scalar and displacement is vector. So we'll go with 1. For work and power, we have different units. For work, we have joule. For power, we have watt. That's a different units. For the force, we have Newton. For the momentum, it's mass into velocity. That is kg meter per second. So it's not matching. Only and only option number A is matching. I mean first, and first is present where? In option number C. That's why C will be the correct answer, right? So guys, time's also up. So I'll do one thing. I'm just sharing this PDF with you people, and guys, do not worry. All the important stuffs. So I have these slides for you. Let me tell you the count also. So the total count of the slides is 130. So total 130 slides are there. in which I have kept all the important PYQs and the most expected questions which we have discussed in the starting of this week. That is Tuesday, scalar vector quantities, then Wednesday, electricity, and then Thursday, magnetism. And today on Friday, we have combined this session. So please let me know in the comment section, do you like this session? Should we continue this series? Please let me know in the comment section. Also, I am giving an homework question, and homework question is this: the dot product of two vector quantities give you dash quantity. So the dot product of the two vector quantities gives us dash quantity. I want this answer in the comment section. Also, please let me know how was this session. Should we continue the series? And if yes, so this week, in the coming week, we'll start with the biology. First, we'll discuss about the cell chapter because there are lots of questions which are asked here. Then this will be discussed on Tuesday. On the Wednesday, we'll discuss the vitamins and minerals. That means the nutrients chapter. And on the Thursday, we'll discuss the heart chapter. That is the blood part. And I'll use the animations also here. Don't worry. And on Friday again, at the same timing, we will have the mixed questions test where you can just test your knowledge. And also, I'll provide the free ebook every Friday. And today also, I'm going to provide that, right? Along with the detailed explanation. And what about Monday? So on Monday, we'll go with the live test. And all these things will be there at 5 p.m. sharp. Fine. So you can meet me daily at 5 p.m. from Monday to Friday. So that's all from my end. Thank you guys. So yes, there are two things that I'll request you all. First of all, please answer about it. And second thing, please let me know, are you liking the series and should we continue the same? So thank you guys. And one more thing, as if you want to prepare from our application, you can just go to the Oliveboard, just click on it, tap here on the first link. Then under SSC part in the dashboard, you will find SSC plus Railway Super Elite Batch where you will have all the English and Hindi medium classes. You will get the live courses, live test, and also test and the notes. So 1200 live sessions are there for SSC. 600 plus live sessions are there for the RRB, 300 plus concept videos, 900 plus mock test, typing test, everything is present here. Just go to the Enroll Now option. There's a code that is going on, that's dead, and we are celebrating Father's Day here. So you can get 59% off by using the code DAD. So I'll just mention here, that is DAD, and you'll apply the coupon code and that's for the maximum discount. So thank you guys for being such a wonderful audience. And yes, for the homework question, this is the homework question that you need to answer. Bye guys, take care. Jai Hind. Love you all. Please take care.